Welcome. I'm going to be talking today about root ports and how we calculate them. So in my previous video we discussed about root bridges, and we determined that this is going to be our root bridge. And with that known, our root bridge, all of its outward facing ports are going to turn to designated ports. And by default, a root port is the forward facing port to the root bridge. So, on example, switch 2. Going towards our root bridge, the interface for switch 2 going that way is going to be our root port. And how it does that is based off of a calculation for the link. And so part of that is a cost value chart. If the link is 10 gig, the cost is 2. If it is a 1 gig link, the cost is 4. If it is a 100 megabit, the cost is 19. And if it is a 10 megabit, the cost is 100. So it's actually going to look for the lowest cost value to determine the paths that are going to stay active. So between switch 1 and switch 0, this port right here is going to be our root port. A switch can only have one root port. So here on switch 3, we have 2 links going that way and that way. One of them will have to be disabled, but you'll notice both have a link cost or a link value for 1 gigabit, so they have a link value of 4. The MAC address is the same, the bridge priority is the same, everything is the same. So it will disable one of the links, and what will happen is that will move to a non-designated port, and the other link will turn to a root port. Again, a root port is just a forward-facing port on a switch that will be heading to the root bridge. So the non-designated port will temporarily disable that link, so it will not pass traffic. Between switches 3 and switches 4, same thing will happen. These will become 2 designated ports. This side will have 2 root ports. And they will realize they have 2 switch ports, so a event will trigger, and one of these links, because again both links are 1 gig, one of these will transition to a non-designated port, and then we'll disable the link completely. And then here our FA0/24 become our root port, and we'll allow traffic to flow out that way. That means if we had a PC here and we had a PC here, it will actually leave our PC, go to switch 3, because this interface right here is disabled. It will actually be forwarded to switch 1, then up to our root bridge, and then over. So this is why you want to be more careful with STP, because you can end up with longer paths if you have not planned this out thoroughly. So again, this is my video on root ports. I wanted to thank you and hope you have a great day.